Hi, I'm Aaron with LGH. Do you lift heavy or awkward loads? Planning for a complicated lift requires careful consideration. However, utilizing a spreader beam is often the best way to distribute weight evenly, reduce stress on slings, and improve load stability. But how do you ensure your setup is safe and efficient? Let's go over adjustable spreader beam stress calculations, as well as some best practices to keep your lift secure. Before any lift, it's critical to understand how load distribution and stress points affect your rigging setup. Incorrect calculations can lead to overloading, bent shackles, or even equipment failure. When using a spreader bar, the total weight of the load is distributed across multiple pick points, unlike a lifted beam, which directly supports the load from a central attachment point. A spreader bar redistributes force through compression in the bar and tension in the slings. This reduces bending stress on the beam and improves load stability. To calculate the correct load distribution, let's use the formula. F equals, which is total load divided by 2, plus the additional sling tension. Here are what these variables mean. F equals the force experienced by each sling and connection point. Total load equals the weight of the object being lifted. 2 equals the number of slings supporting the spreader beam. We're assuming a 2-leg setup here. Additional sling tension equals the increased force due to sling angle effects. To demonstrate, let's say we are lifting a 10,000-pound load using a modulift spreader beam with 2 slings at a 60-degree angle. Basic force distribution without sling angle effects, the load is split equally between the 2 slings. F equals 10,000 divided by 2, which would equal 5,000 pounds per sling. Accounting for sling angle tension, when slings are not perfectly vertical, they experienced increased tension due to the angle of pull. We must account for sling angle tension in our calculations. Accounting for sling angle tension, when slings are not perfectly vertical, they experience increased tension due to the angle of pull. We must account for the sling angle tension in our calculations. For example, with a 60-degree sling angle, the tension factor is 1.154. We will take a closer look at a tension factor graph in a moment. Therefore, the actual tension in each sling is 5,000 times 1.154, which equals 5,770 pounds per sling. Now, if the sling angles are too wide, the tension can overload your shackles, slings, or even the spreader beam itself. Properly calculating these forces is crucial to prevent rigging failure and ensure a safe lift. By using a spreader beam instead of a lifting beam, you distribute the weight more evenly. This reduces bending stress and improves overall load stability. Understanding sling angles is critical for safe rigging. As the angle from horizontal decreases, the tension in each sling leg increases, putting extra stress on your rigging components. The ideal angle is close to 90 degrees, where angles below 30 degrees are generally unsafe due to excessive tension. To determine the correct sling capacity, you need to calculate the load angle factor, or LAF, or tension factor, TF. Start by measuring your sling angle, or the ratio sling length, L, to height, H. Using an angle chart, you can determine the correct sling rating for your lift. To check if your sling capacity is reduced at a specific angle, determine the reduction factor, or RF, by dividing the sling height, H, by its length, L. Then multiply the RF by the sling's rated capacity to get the adjusted safe working load. Proper sling angle calculations help prevent overloads, reducing stress on shackles, lifting beams, and spreader bars, ensuring a safe and efficient lift. Finally, you can follow the safety checklist to complete before every lift. Verify the working load limit of the spreader beam, slings, and shackles. Ensure the beam is properly balanced. Uneven loads create unsafe stress conditions. Check for any equipment wear, damage, or deformation, especially at connection points. Maintain proper sling angles. 45 to 60 degrees is ideal for most lifts. Use the correct shackle size and type. Bolt-type shackles are best for long-term setups, while screw-pin shackles work well for temporary lifts. By mastering adjustable spreader beam stress calculations and following these safety best practices, you'll ensure every lift is secure, efficient, and compliant with industry standards. Looking for rigging equipment or just need some expert insight? Visit us at rentlgh.com today. And if you enjoyed this video, don't forget to like and subscribe. Happy lifting!